let us see the sampling problem. In 324 throws of a 6-faced die, an odd number turned up 181 times. Is it reasonable to think that the die is unbiased? So before we start the question, we have to first fix whether it's a one-tail or two-tail test. So how do you identify one-tail or two-tail test? So how do you identify this? So whenever they ask the question whether the die is unbiased or the coin is unbiased, it means we have to fix the null hypothesis H0. Okay, null hypothesis H0 that the die is unbiased. So if I say unbiased, it means the observed number of success should be almost equal to the expected number of success, correct? So whenever I say it is almost equal, then it can be less also, it can be greater also. So if I have two options, less as well as greater, see, equal is a null hypothesis, not equal means it can be lesser or greater. We have two options, so we will go for a two-tail test. Okay, so for this problem, I have decided that I'll go for a two-tail test. What are the values that I have to compare for a two-tail test? 1.96 at 5% significance level and 2.58 at 1% significance level. So these are the values I have to compare with. Now I'm clear with one thing, that I'm going for a two-tail test. Now what are the things that they have given? So how many times we are repeating the experiment? 324 times. So we have n is equal to 324, the system. So what is P? P is the probability of odd number turned up. Okay. What is the probability of how many odd numbers are there in a die? So total you have 1, 3 numbers we have out of 1, 2, 3, 4, 5, 6. So out of 6 options, these 3 are the odd numbers. So I will write 3 by 6, which is nothing but 1 by 2. Okay. So P is nothing but 1 by 2. I have fixed the probability of getting an odd number. So Q is nothing but 1 minus P, that is 1 minus 1 by 2. That is equal to 1 by 2. So now we have P, Q, what are the values we have? N 324, P 1 by 2 and Q 1 by 2. So we are done with these values. Now what is the formula for the Z value? Z is equal to x minus NP by root of NPQ. So what is this x? Sometimes we may say x bar or the mean. So normally here NP is nothing but, from here itself you can find NP is 324 into 1 by 2, which is nothing but 324 by 2, which is nothing but 162. So this is 162. So what we got and what we have to get it, that both we are going to compare. Okay. So observed number of success is 181. So observed number of success is 181. This is observed number. It's like 181 times odd number came, and so 181 minus this NP already I've calculated, that is 162. 181 minus 162 by root of N is 324 times we have thrown the dice. So into 1 by 2 into 1 by 2. If you calculate this, we will get 2.11. Okay. So now in the question, if they ask percentage level, then you can compare with this, because I have given two values, 1.96 at 5%, 2.58 at 1%. Always we give the conclusion confidently at 1% result. So if you want to conclude the result, then you write 2.11 is less than 2.58 at 2.58 is 1% significance level. Therefore, so it is in the acceptance region. Okay, so we accept the hypothesis, the null hypothesis or null hypothesis H0. What is your null hypothesis? My null hypothesis H0 is the die is unbiased. So we conclude that the die is unbiased. See, when you are writing we conclude that the die is unbiased at 1% significance level. So in case if in the question if they ask for 5%, what is the result in the case of 5% means 2.11 is greater than 1.96 at 5% significance level. Therefore, we will reject the hypothesis at 5%. Reject the hypothesis at 5% significance level. So, you understood the difference, significance level. Ignore my verse handwriting. So, if they don't mention anything, you conclude the result with 1%. And in case if they ask at 5%, you have to compare with this value. So, what made you to compare with this value? Because we have decided to go for a two-tailed test. Whenever the die is unbiased or the coin is unbiased, then you go for a two-tailed test. See this problem. A manufacturer claimed that at least 95% of the equipment which he supplied to a factory conformed to specifications. An examination of a sample of 200 pieces of equipment revealed that 80 of them were, oh my god, faulty. Testers claim at a significance level of 1% and 5%. Okay. So now in the solution, first of all, what we have to decide? Whether it's one tail or two tail. What do you think? It could be a one tail test or two tail test. Whenever I say something you have to compare that equal, then it will go for a two tail test. Okay, now what I have to check for? So I am framing the hypothesis that his claim is correct. So what do you mean by that? At least 95% of the equipments are good enough. Okay, so when I say at least 95%, it means 95 and above. So we are seeing only one side. So it is a one-tail test. So when his claim will be false, when this probability is less than 95, only false. There are no two options, only one option. If it is greater than 95 means 95% means 95% is same as 95 by 100, 0.95. So if it is greater than, so his claim is this probability will be greater than 0.95. If his claim is correct means this is what it means. If his claim is wrong means, so only one side we are comparing, so it is a one-tail test. When this is exactly equal means it could be less than or greater than, so it is a two-tail test we say. So already his claim is, his specification is at least 95% of the equipments are up to the specifications. So we have decided that it's a one-tail test. Okay. So now once we decided it is a one-tail test, what are the values we have to compare? Because in the question they asked at both 1% and 5%. So it is 1.645 at 5% and 2.33. Let me complete this significance. And 2.33 at 1% significance level. Okay, so these are the values I have to compare with. So now I will start the same formula. Z is equal to x minus np by root of npq. So first of all, n I have to write. Okay, so what is n? They have checked how many samples? 200 samples, right? So n is 200. Okay, n means how many times I am repeating that number. So next is p. So he is saying that 95% are up to the specification. So 95, let me write this, 95 by 100, that is equal to 0.95. Okay, so if P is 0.95, Q is 1 minus P, 0.05. Okay, so this P is nothing but, again, the probability of success only. We will write probability of success. What do you mean by probability of success? It means, this fellow said, right, that probability of equipment supplied to the factory conformal to the specifications. Let me write this. Written is, so it is nothing but the probability of equipment supplied to the factory conformal to the specifications. So he said 95% definitely will conform to the specification. So we have taken P as 95%, which is 0.95. So we know what is N, P, Q. Then what we have to find? NP also, right? So NP is 200 into 0.95, that's equal to 190. So NP is 190, I know, but in the numerator X minus NP is there, right? 1 is what we are supposed to get. Here it is what we got actually observed. Correct? So NP is 190 as per the calculation, but expected number of equipments according to the specification need to be 190. But what is the actual now? This is expected. Expected number of equipments according to specification. According to, I have written the same thing. Expected number of equipments according to the specification, it should be 190. But actually how much? If we check in the total of 200, 18 were faulty. Correct? So 200 minus 18 is the actual number of equipments that are good, that are up to the specifications. So what we are supposed to get? 190. But what we got is 182, because in the question they have mentioned that out of 200 sample piece, 18 of them were faulty. So how many good ones? 200 minus 18, that is 182 good ones. But as per his specification, how much it should be? 190. So your Z is, when you write the formula, X minus mu, sorry, I'll write it, X minus NP by root of NPQ. This I can write it as mu also, both are same. So 190 minus 182 by root of N is 200, P is 0.95 into Q is 0.05. So make sure that the bigger number minus smaller number you are writing in the numerator. So, or what you will write? You will write modulus. You can write modulus also, because this is nothing but the difference. I want to note the difference, so I will write only the positive value. So if you write 182 minus 190, then you put modulus, or you write 190 minus 182 in the numerator. Okay. So this is the numerator. I will write Z is equal to X minus NP, that is 190 minus 182 is the numerator. I will write 8. So divided by the square root of everything. If you calculate, you will get 3.082. So this is 2.6. They've asked us to check at both 1% and 5% significance level. So 2.6 is greater than 1.645 at 5% significance level, because this is the value for the one-tail test. Okay, so significance level, and 2.6 is greater than 2.33 at 1% significance level. So both the places it is greater than, so we will reject the hypothesis. When I say reject the hypothesis, since it is greater, we have rejected. It means if it is within this region, that is the 95% acceptance region, that is if it falls within this, means then I will write less than. Okay, here it is not falling in this region, it is somewhere outside. But again at 1% significant level, 2.33. Again, I'm checking in this region now at least. So here also it doesn't fall within the region. So your answer is outside the region. So it means we are rejecting the hypothesis. So what is your null hypothesis? The manufacturer claim is null hypothesis. His claim is correct. That is what we have written. So we conclude that the claim of the manufacturer is rejected at both the levels, 1% as well as 5%. So what he claimed that at least 95% of the equipment which he supplied to a factory conform to specifications. So this is wrong. Okay. So coming to one tail and two tail test. For one tail, I will give you certain words. That is, at least here they said, better than, superior, inferior, all those things will come for one tail. So when you will go for a two tail test, check whether they are equal. So whenever I say equal, so there is no difference. There is no difference means automatically it is equal. There is no difference or there is no significant difference. All those things will fall under two tail. So whenever I say equal, then it can be less than or greater than. So we are going for a two tail test. Whenever I say at least, better, superior, inferior, it's like comparatively I'm asking that which is better, then in that case we'll go for a one tail test.